Duncan, your documentary on Neil Armstrong was one of the best bits of TV I saw in 2012. It was superb. I've
Oh,
seen I've seen so
thank you.
many documentaries over the years, but just about every single piece of footage, just about every single still you showed, I could not remember seeing before. Now that might be my failing mid-40s memory, but I think it was a lot of new material in there. So, and they were
Yeah,
fantastic interviews.
thank you, thank you. No, we were pretty lucky with the access and with getting the archive as well. I mean, we really trawled, and I think, fortunately, we're in a position now where after sort of 15 years of going through the NASA archive, we tend to get what we want and know
Mm.
who to talk to get it, which is half the battle, and to get the access as well, to get interviews with the family. Again, it's really just
Well,
that.
that was the other thing that I had never seen before. I don't ever recall seeing an interview with any of his family, and to get his brother, there and his ex-wife. I mean, it was just such an insight into, such a private, what always seemed a very fragile man, and he kind of came
Yeah,
over in that, I think.
yeah,
But
yeah. No,
superb, absolutely loved it.
thank you very much. Thank you. It's fun to make.
So the Slooh Space Camera broadcast of Asteroid Apophis will begin in about 3 minutes. About 3 minutes. Broadcast of Apophis will begin in about 2 minutes. You should be viewing this on slooh.com. That's slooh.com to get the live visuals. We will be attempting to screen share it at times, but to start the broadcast out, some of the visuals you'll have to go to slooh.com.
Duncan, did you watch Stargazing Live tonight?
I didn't. No, I forgot to watch it. I
Oh
forgot to.
no!
It's normally quite good. I mean, I think it's quite. It's one of the more successful live events that the Beat did. I mean, I know
Yeah,
they did this Volcanoes live, and I didn't think that was that.
yeah.
Um,
It didn't quite come off, did it? But
it's not really a difficult thing to do, I think, actually.
yeah, yeah.
Uh, but I normally watch the Stargate. Did you see it? Was it good?
Yeah, yeah, yeah. They're a
Did
good
it
mix,
work?
I think. Yeah, I mean, it's unfortunate they didn't have many live feeds. They should have used some of ours, perhaps. But they're always entertaining. In fact, I always love the after show half an hour that they do. That's way more entertaining usually. So that was great fun.
I'll have to catch up on iPlayer.
It looks like Pat may have come and gone. Oh no, he's still in there. Got two of you in the hangout, Pat.
Yeah, I've got two as well.
It's nice to have you. Double Pat. Yeah, Bob and I continued broadcasting for about 20 minutes on a show where the Hangout had crashed, and we both thought it was the best 20 minutes broadcasting either of us had ever done, but it didn't go out to anybody.
We had the same when we had one of the Apollo engineers, and we were
Mm.
just chatting away, and he's brilliant, this chap, and we were just it was fantastic, and then I realised this isn't going out at all. It was really disappointing. But hey,
very frustrating.
yeah, it can be.
No, he is there.
He's there, but I can't hear him. Can you?
No.
So do we refresh?
No, not at the moment, Duncan. If he's in the Hangout, it's probably just his audio needs to be switched on.
All right.
Just for everybody. Oh, he's back.
Is that better? Okay.
Yep.
Yeah, guys, sorry about that technical issue. Hi, this is Patrick Colucci with Sloohs Space Camera. Welcome to our show on Asteroid Apophis. It is this January 9th, 2013. Happy New Year to everyone out there. And we're here today with a special panel to watch live Asteroid Apophis make its close approach to Earth. Now, with us today, we'll be actually watching this live from the Canary Islands Observatory, Sloohs Canary Islands Observatory. And with us today is a unique panel of experts. With us, we have documentary filmmaker Duncan Kopp. Perhaps you've run across some of Duncan's work either on the Science Channel, Nat Geo Discovery. Also, he has produced several different types of films, including an award winner at Sundance. I guess it was the International Award winner at 2007 called In the Shadow of the Moon. Duncan's been on a lot of our shows in the past, including one of our biggest ever, which was with the Google and the Google Doodle Lunar Eclipse event that took place in 2011. Duncan, thank you for joining us again. It's great to have you on.
Thanks, Pat. It's great to be here.
Awesome. And with us also is Slooh Outreach Coordinator and Engineer Paul Cox. Paul's been with Slooh for quite some time now. For those of you who don't know anything about Slooh, we've been around since 2003. We own and operate our own observatories worldwide, and we provide access to those observatories through membership. And it's a unique opportunity for people of all ages and all levels to command our telescopes, and we're using those same telescopes tonight. Paul is actually manually controlling these. Both Paul and Duncan are in the UK commanding our scopes. I should say Paul is commanding the scopes in the UK, and he's doing that remotely. So this is a robotic facility on a mountaintop in the Canary Islands, and for those of you who don't know anything about where that is, that's off the coast of Africa. So anyway, guys, here we are. We're broadcasting live to the world right now. There's a lot of interest in this particular event due to not necessarily the event itself tonight, but what may happen down the road. For those of you who don't know, and Duncan and Paul will definitely talk more about this, this particular asteroid, and just to give you an idea, Paul is doing, this is a live feed that you're seeing. If you want to see the live visuals right now, you have to go to slooh.com because Paul is actually controlling the scopes, and he's not going to be able to screen share in quite yet to this hangout. So go to slooh.com to see the actual feed itself. But anyway, guys, this particular asteroid, people are worried about the future. Now, when it was first discovered, and you guys could educate us all here, perhaps, Duncan, you could start out here. I believe in 2004 it was discovered by some astronomers at Kitt Peak Observatory. And at the time, they thought it was a pretty high probability that it could hit Earth in 2029. However, that sense has been revised a little bit. Duncan, perhaps you could talk to us a little bit about maybe the history of this asteroid and the concern that it's driving worldwide because of not only in 2029, but also 2036.
Sure, yeah, no, absolutely, be delighted to. I mean, first of all, let's take a sort of 101 with regards to asteroids. I mean, asteroids are the rubble, if you like, the leftovers of the formation of the solar system. And so they're very, very old, and in that sense, they're sort of postcards from the past. They're really interesting because they can tell us about conditions and about the material that our solar system actually formed from, the planets formed from. So from that perspective, they're really, really interesting objects. But they're sort of a double-edged sword because what we know now is asteroids that stray too close to Earth have the potential of hitting Earth, and indeed in the past have hit Earth. And there are a number of really very obvious impact craters on the planet, on our planet. We know we can be struck by these things. And in fact, the best way to know is actually only look 250,000 miles away and have a look at the moon. The moon is absolutely covered with impacts, and they come from asteroids and comets and smaller bits of rock which are flying out there. The only reason we have less impacts on our planet, or we can see less impacts on our planet, is because they get worn away, because we have an atmosphere, we have water, and we have agents that weather them away, so we can't see them. But that doesn't mean to say that they don't hit us, because they do. So with this particular asteroid, which was discovered in 2004, we knew that at the time there was a possibility, a very slight possibility, in fact it was about 2.7%, so really, really small, that this thing would hit in the future. But since then, with greater, I guess, observations, we're able to try and narrow down more precisely what the chances are. And tonight, the asteroid is actually something like 9 million miles away from us. Now that may sound close, but as I said, the moon is 250,000 miles away, so this thing is 35, 36 times further away from the moon, so there's absolutely no chance that it's going to hit us tonight during this encounter. But as you pointed out, Pat, it's what's going to happen in the future. And that's a little less certain, but what's brilliant about the encounter this year is we've got an opportunity to study this asteroid in greater detail. And hopefully be able to narrow down what will happen when it passes again in I think it's 16 years' time, in I think it's 2029, and then again in 23 years' time, which is 2036. So
Right.
really, all eyes on it tonight to see and learn as much as we can, and try and pinpoint what's going to happen in the future in those two encounters that I told you about.
So if you're joining us right now, Paul Cox is pointing our telescope at this asteroid live from the Canary Islands. And maybe, Paul, if you're there, I know Paul's busy right now tracking this thing. You could help explain what we're seeing on Slooh.com right now. Now, Paul will try to screen share in this image at some point during the presentation, but he is tied up controlling the scope. So, Paul, what could you tell us about the actual asteroid and what we're seeing right now?
Yeah, so people on the home page, you need to be looking at what's called the T2 high mag telescope view, and that's the view within that big circle, and you'll see a lot of kind of oval objects. Those are all stars, and then you'll see just below the center of the image there's a kind of perfectly round star. Now that's the asteroid. This is moving a bit slower. The relative velocity is a bit slower in comparison to a lot of the asteroids we've seen. That's because of how far away it is, primarily. But we're going to see it. We're going to see that small dot, this tiny, tiny little asteroid, which, as Duncan says, is a whole bucket load of millions of miles away at the moment. And we're going to track it, and we're going to see it slowly move across those background stars. We're actually tracking at the asteroid's rate, so that's why we're seeing the stars in the background trailing. This is a pretty faint asteroid because it's quite small, so that's why it's, you know, such a small little dot, really.
Well, one of the interesting things about this whole event is, although that asteroid is technically small, and I believe it's 270 meters, or about, if you live in the United States, that's about 300 yards, which is equivalent to 3 football fields. I read somewhere, Duncan, that if this thing, though, hit Earth, that it would be equivalent to 100,000 Hiroshima bombs. So while it is technically pretty small, it still could inflict quite a bit of damage on the planet. You know, perhaps, what's your thoughts on that, and how that relates to these objects that are zipping around the solar system and the risk that they pose? Because, yeah, this thing's not that big, really, but it could inflict quite a bit of damage if it did impact the planet.
Yeah, no, absolutely. I mean, there's no doubt about that. I mean, these near-Earth asteroids, if they hit us, can release a lot of energy. And, you know, let's go back to the dinosaurs, 65 million years ago. It's estimated that something about 15 kilometers in size struck the Earth then, you know, but that had 100 million megaton impact, and you know, that's pretty big. I think I read somewhere that Apophis, if it strikes, is something like 500 megatons, something like that.
Yeah, 510.
Yeah, was it okay? 510. Thanks, Paul.
And
So
that's megatons of TNT equivalent.
Exactly. So we're still, you know, in terms of a nuclear weapon, that's still pretty mighty.
Well, the biggest, I looked at this today, Duncan, the biggest hydrogen bomb was Tsar Bomba, and that was 50 megatons, the equivalent of 50 megatons.
Exactly. That was a Russian detonation. Yeah, pretty big. So, I mean, you know, no bones about it. These asteroids carry a lot of clout if they hit us, but it's really understanding the statistical chances of them hitting us. I think that's what's really important. And I think there are a couple of things to think about. I mean, firstly, what's being demonstrated with this particular asteroid is actually, you know, they don't really come out of the blue. There's actually quite a lot of time from discovering them and tracking them and understanding them. So normally, I think it's fairly safe to say, you know, we're going to have a fair warning. But what's important, I think, about tonight's event is what it shows us is as our ability to be able to study the solar system improves and we learn more about these objects, and in fact we find and discover more of these objects, we're going to want to know more about them. And it's really important that we track them so that we're able to understand, you know, what are the chances of something like this hitting us? And if it does hit us, how energetic will it be? And perhaps, you know, what will the consequences be? Now, I think there's about 1,000 near-Earth objects that are, I think, over a kilometre, over 1,000 metres in size. But when you get down to the size of about 40 metres, which is, I don't know, about the size of a big office block, there's calculated to be 1 million plus. So we know that there are a lot of these chunks out there. So it's really important to try and understand, try and follow them, try and get an idea of what we could do if we did find one that perhaps was going to stray too close to us.
So if you're just joining us right now, we're looking at live views of Asteroid Apophis on the homepage of Slooh.com. Paul Cox, who's in the UK, is controlling our robotic observatory in the Canary Islands. He will try to screen share into the Hangout at some point. Once he's further along in the presentation, he has to obviously, he's tracking this thing right now live, so he's got to keep his head down on the equipment. We're also with filmmaker Duncan Kopp, who's produced a lot of different projects for such entities as Discovery Channel, Nat Geo, Science Channel, and such, and NASA. And some of the stuff he's produced is, you probably run across it, including a project by the name of In the Shadow of the Moon, which is an award winner at Sundance for International in 2007. Moon Machines comes to mind. There's a whole list. In fact, I've got Duncan's bio right here, buddy. I was looking at it. You know, I mean, how many pages do I have to read to get through this, man?
Oh, please.
Oh my gosh, mine's only like a paragraph. No, but anyway, so Duncan's a well-accomplished filmmaker in space and science, and we're privileged to have him on here with us. Unfortunately, Bob Berman wanted to join us as well, but he is on his way to Chile for a separate project that he's working on. And so, but anyway, we're here live with you tonight. We're giving you live views of this particular event, Asteroid Apophis. And as these guys have been alluding to, the actual asteroid right now tonight technically is not that close. It is 9 million miles away, I guess, right now on its close approach to Earth. If you go to Slooh.com, there in the box number 2, there is an orbit diagram that was provided by NASA that we reproduced, and we put on the homepage there. You can look at it and see how it's traveling around the solar system right now. It's pretty cool to see that and its relationship to Earth. But the issue at hand is what it's going to happen down the road. I mean, the concern of why everyone's so interested in this particular asteroid is in 2029, when it's going to be coming in at a much closer, I guess, 30,000-ish kilometer range, which is basically where our satellites are on Earth. So it's going to be a lot closer. And then, of course, down the road in 2036, I've read, and I don't know, I've read that some things are changing now. I mean, I'm hoping that they get more information on this close approach over the next couple of days. But I've been reading that it's about a 1 in 250,000 chance that it could strike Earth in 2036. So it's not a very likely event, but it's still probable that it could happen. And so that's the big fear factor that we're dealing with tonight. Paul, perhaps it looks like you're screen sharing stuff in right now. I'm going to put it up there. Maybe you could point to where the asteroid is in right now so people can kind of see it. It's a little harder to see because it's so far away, and it's not that big. It's only 300 yards big. So perhaps, Paul, you can tell us. Yeah, it looks like you're pointing to it right now.
And I think we all need to really think about that properly. You know, we're looking at an object 9 million miles away, which, depending upon which data you look at, is anywhere between 270 to 340 meters in diameter. We don't even know what shape it is, and we're able to track this thing from the Slooh telescopes on the top of Mount Teide, which is in the Canary Islands. You know, it might just be a small white dot, and it's the small round dot in there, but it's pretty damn amazing that we're able to actually pick out an object of that size moving that fast and see it very clearly against the background stars. And just as a reminder to everybody, the asteroid is moving in relation to the background stars, and I'm actually controlling the telescope so it tracks the asteroid. So the asteroid stays nice and round, but the stars in the background are trailing as the asteroid moves during each exposure. And anybody who's interested, the exposures that we're doing tonight are 120 seconds. So just keep an eye open. It's going to be really the only round object in the middle of each image.
No, it is fascinating, Paul, they're able to do this. And guys, if you're on the home page, there's a lot of ways that people can ask questions for Slooh, but the best way is to go to Slooh.com and click the Slooh conversation box. And we'll monitor that. If you have a question for Duncan, Paul, or myself, we'll try to get to them throughout the show. We will be broadcasting in 2 shows tonight. This show will go for about 45 minutes, so we got another half hour left in this broadcast. And then we will start up another show, Paul and I. And Duncan, if you're around, I didn't think you'd want to stay up so late, but if you're up for some reason, you're more than welcome to come on the second broadcast that we're going to be doing at about another hour and a half. So but we're going to do another one because of the interest level in this particular item, this particular object tonight. So anyway, guys, what else can you tell us, Duncan? I mean, about these asteroids in general, because you mentioned there was millions of them rolling around the solar system. Isn't that kind of a big concern in itself? I mean, how are we able to track those? Because that seems like an awful lot to get our hands around.
Well, yeah, I mean, the vast majority of asteroids are contained in what we call the asteroid belt, and that's an area between Mars and Jupiter. And the idea there is perhaps it's a planet that didn't quite get it together, so you've just got the rubbly remains that exists out there. But as I said, you know, these near-Earth asteroids are prime examples. Some of them stray within the orbit of Mars and find themselves heading in towards us. And it's not just asteroids, it's comets as well. And in fact, it's thought that the comet struck in Tunguska in the very beginning of the 20th century, and you know, with a big impact, wiped out a very large area of forest. And even today, if you go there, the trees that were standing straight were all knocked over like matchsticks because of this impact. Well, it was actually what's considered to happen is it impacted the atmosphere and exploded in the atmosphere and caused the shockwave. So yeah, no, there's a lot of them out there. But I think the other reason why asteroids are so interesting is because, as I say, they contain the sort of secrets as to what was around when our solar system was formed. And also, as we're discovering, some of them are actually pretty well stocked up on rare earth elements and minerals and metals. So they could actually have a value in terms of commodities, mining. And there are some very interesting developments with regards to private entities now that are looking to actually control an asteroid, bring it in to a near-Earth orbit, and mine it, which is fascinating. So again, it's this sort of double-edged sword. Asteroids, in some respects, could be our savior, but also they could be something that could cause considerable damage here on Earth if one was to hit us. And Pat, you know, you were talking about the encounter in 2039 with Apophis, and that's when we really want to look out for this particular asteroid, because as you've mentioned, it's going to come within the orbiting height of what we call our geostationary, geosynchronous satellites, the ones that basically always have one face turning towards the Earth. They basically revolve around the Earth at the same rate that the Earth turns round, if you like. So they're always in one place. And that's about 36,000 miles or something like that, 36,000 kilometers. So that's pretty close, although what's interesting is the way that the asteroid will actually come towards us, its inclination, if you like, means that it's not likely to hit any of the satellites at all, but it'll still come pretty close to us.
Right. Well, if you're just joining us, guys, the presentation, Paul will be screen sharing in the asteroid views as best he can. He is in right now tied up commanding the robotic scope that's in the Canary Islands, which is off the coast of Africa. You're looking at live views if you're on Slooh.com of the asteroid. It is about 9 million miles away right now, so you can imagine it's very difficult to see. It's a little dim, but we are tracking it, and it is fascinating that Paul is able to actually get his hands around this thing that's so far away. And it's not really fast moving, because sometimes the asteroid events that we do, you can really see it whizzing by the stars as a dot or a shape. And whereas this one's a little bit more difficult to see among the other objects out there. But
Pat, I mean, you say it's not moving fast, but that's kind of relative. The relative velocity of this thing is 9,149 miles an hour. Now, in my book, that's faster than my motorbike. So
yeah, you're right. You're right, man. I apologize. I apologize. I just want to throw a quick shout out to Slooh membership. It does fund all the programming we produce. We do shows weekly on different subjects of all types. They're all live. We point our telescopes out there, and it really funds all this stuff. So there is a Join Slooh Today button. You'll see it on the homepage of Slooh. Consider it. If you can't afford it, if you do join, by the way, you get to control these very same telescopes that Paul's actually controlling now. And it's very easy. We built this thing to be very easy for people to command. And it's fun. There's a great group of community worldwide that participates. You can go on any mission that any member points to. It's from beginner. You get PNG file images, or if you're an expert or a guy who understands FITS data, you can get access to that as well. So it's a very unique community. Please consider it. But if you can't afford it, and I understand due to the economic difficulties and such, please consider joining us for signing up. And what you can do is just hit that contribution button as well. That's another option for you to consider as well. I am going to start monitoring the conversation section a little closer. It's been, time's been flying by. So if you do have some questions you want to ask us, Duncan, there is some questions about if this did hit the Earth, or an asteroid did hit the Earth, would it change the Earth's orbit or anything like that, or like the rotation of the Earth? Would anything like that occur?
Pretty unlikely. In fact, nothing that would be noticeable if you're talking about a relatively small near-Earth asteroid.
Yeah, this one wouldn't do that.
It would have to be pretty big to do something like that. We're talking, thousands of kilometers, probably hundreds or thousands of kilometers to have any effect, if at all. So no real effect with regards to the orbit or the inclination or the rotation of the Earth at all.
We do, though, have projections on exactly what kind of damage this thing would do, and they reckon it would devastate thousands of square kilometers. We actually know roughly, with the current orbital solutions, we know roughly where it would hit. And for instance, they've done some calculations, and Colombia and Venezuela are both on the path of risk, and they reckon that could have more than 10 million casualties, an object of this particular size. So we're talking about this particular object. Now, if it hit, a potentially worse case would be if it hit the Atlantic or Pacific Ocean, in which case it would obviously generate a whole series of giant tsunamis, in which case the damage that can cause we've all seen in very recent history. And actually, while I'm on, Duncan, I would take issue actually with one thing that you said very early on, and that is that, you know, we have plenty of warning with these things. Well, yeah, this one was discovered in 2004, but we covered live last year half a dozen, 3 of which were very large asteroids, which made their closest approaches to Earth between 4 days and 10 days of their first discovery. In other words, very large asteroids, which we only had 4 to 7 days warning of before they made their closest approach. So that, I think, we are still being taken by surprise, and actually 2012 was quite an extreme example of that, with the size of some of these objects that were coming in really late.
Yeah, no, you're quite right, Paul, and I stand corrected. It's more an issue of, I think, if you're going to have something, well, to try and track everything is nigh on impossible. I think I was really referring to the ones that we already know about. But if you know, as you point out, there are perhaps an order of magnitude more that we don't know about, and the chances of finding them in the future and being able to track them, nobody really knows, because, as you say, you know, they can swing past in a matter of days. I think I was really referring to the ones that we do know about, and if there were any perturbation in their orbit, if all of a sudden, you know, for some reason they had a particular close encounter with the moon or the Earth, and their orbit were to change, we would have time to be able to calculate that. So that's really what I was driving at there. But you're absolutely right. I mean, for every asteroid that we do know, you know, as I say, there could be 100 or 1,000 more similar ones out there, and who knows what they're going to do? No idea at all. And that's why it's really important, I think, to have institutions that are constantly, you know, out there looking for these objects. And in that respect, you know, it's quite an important area that I think needs quite a lot of funding, and it shouldn't be neglected, really, because this really shows us exactly why we would want to understand.
But you say that we understand this one. We don't. We don't understand this, and we have been observing it since 2004. And if you actually track the projections and the chances of impact, they changed on a daily basis, literally a daily basis, fluctuating from 1 in 20,000 to 1 in 500,000 and back again, all within the case of the 23rd of December to the end of that year, just within a few-day period. And it's carried on like that with every observation that we've had, and that's why we still don't know about this object and what it's going to do. For instance, you said that, you know, we know and we can project what's going to happen to these objects if they go past the moon or other objects. Apophis is actually due to encounter another asteroid called 2004 VD17 in 2034. Now, we don't understand these objects at all. We don't even know how big Apophis is, let alone how it can then be affected. And there are an awful lot of things that do affect the actual orbit and the way that the orbit changes. We don't know the physical shape. We don't know how this object is rotating. Those are 2 factors that affect the orbit quite dramatically. You know, so there are these...
The mass as well is something that's also very important, and trying to pin those things down, you know, are what really will give us a handle. And the other thing that I was reading, I think is really interesting, perhaps a little unknown, is just the solar radiation, just the energy from the sun is with the heating and the cooling of this asteroid, that can also change its path, and depending on how that affects the asteroid, you know, that can have big implications down the line. So no, I agree with that, but I think with this particular asteroid, I think what I wanted to get across is we know enough that it's about it at the moment that it ain't going to strike us tonight during this encounter. What happens? What happens down the line becomes more vague, but still statistically, you know, a 1 in 250,000 chance of an impact is pretty slight.
Hey, Paul, why don't you show us, since you've got it screen shared in there, where the asteroid is with your cursor, so people can see it properly and keep track of it.
It's the bright white dot. It's the object that is circular. So it's a point source because we're tracking it with the telescope. It's moving against the background stars. So sorry, I hadn't realized I'd kept my screen share on there. Yeah, the long items, the oval objects, those are stars in the background that are tracking across. So.
Okay, so if you're just joining us, we're here looking at Asteroid Apophis live from our Canary Islands Observatory with filmmaker Duncan Kopp, who many projects you probably run across on Nat Geo, Discovery Channel, Science, and Films, award-winning stuff from In Shadow and the Moon. We also have Slooh engineer Paul Cox commanding these scopes in the Canary Islands right now, and we're looking at it live. It is usually you'll see it as a circular dot among what Paul was saying, the background stars. You can see it on Slooh.com right now while he's tracking the image as we speak. If you have any questions in the Slooh conversation section, I will be monitoring it as we go. We've got about 15 to 20 more minutes in this particular broadcast. So if you want to keep updated on upcoming events, you can always come to Slooh.com and just look at the countdown, the next event, or follow us on Twitter, Facebook, G+, whatever your preference is. And we usually put out tweets, things like that, prior to events, so you can keep updated if you'd like to know when the next show is going to happen. For this particular night, we are going to do a second show tracking this asteroid. That will begin right now. Paul, I have us down at 02 UTC, which is basically, I think that's 6 Pacific, 9 Eastern. So Paul and I will be
an hour and a half's time.
Yeah, so we'll come back on. Duncan, if you love to come back on and battle it out with Paul again, you guys are welcome.
Yeah, please come back, Duncan. Please come back, because I think these are really important issues that we need to deal with, and because it all goes to public perception, and I think it's too easy to scaremonger. But equally, I've always said that actually you don't need to sensationalize these things because they are sensational in any case. The fact that we've known about this object since 2004 and that we still can't establish how much of a threat it is to Earth, and this is one that we know about, to me is actually quite awe-inspiring and just goes to show, you know, what we're dealing with, what a dynamic place we live, this solar system that we call home. Yeah.
For sure. No, I wouldn't disagree with that. I think the only thing I would slightly take issue is that I think, you know, this particular asteroid, even if you do all the calculations, the chances are still pretty slim that this thing's going to hit us. I mean, a 1 in a quarter of a million chance is pretty low. And even when it was discovered, I think it was something like 2.7%, which was eventually sort of whittled away to nothing with regards to the impact hazard at the time. But I think what's more interesting is what you've pointed out about how dynamic the solar system is, and that's perhaps something that's more important these days, because I think as we learn more about the solar system, and this is in every sort of category really, we realise that it's actually a far more dynamic place than we ever even imagined. I mean, you know, it was always a very when I was sort of growing up, you know, it was always a sort of static place. Things happened every 100 million years, whatever. No, not at all. That's just not the case, be it weather on Saturn, you know, be it an impact on Jupiter. I mean, we've seen these things before hit. We've actually had...
we watched it live, last year.
Yeah, absolutely. And you know, Schumacher Levy 9 was another classic example. I mean, these things happen. We know they happen. We've experienced them in the last 25 years. We've learned a lot about them. A lot more. I agree with you. A lot more to learn. But I think you know, we're making pretty good progress. I think what's really interesting, perhaps, to talk about is what happens if we do find one that could hit.
Yeah.
You know, what's the possibility of being able to deflect it? What mechanisms can be put into place to do that? And you know, there are some pretty ingenious ideas out there. And in fact, I think ESA ran a competition to try and find the best idea, could try and nudge one of these things away, or whether
what's the name of the organisation, Duncan? B612 something or other, or it's something like that?
Yeah, B612. It's an organisation that I think is headed up by the Apollo 9 astronaut Rusty Schweiger, I think it is. And B612, if you're interested, is the name of the asteroid in the book The Little Prince, which is all about the asteroid.
Oh, right, okay.
But their organisation is one of these organisations I was talking about earlier that really exists to try and understand the potential threat of asteroid impacts. And, they're very important organizations, as you pointed out, because, we still are learning, and there's a lot more to learn. And the more you observe, obviously, the more you learn. But the catch-22 is getting the funds to do the observations. It's one of those circumstances where until we really have amassed a lot of data,
the observations, Duncan, the observations are one thing, but we've got to somehow test this. Now, wasn't there a large solar sail tested a couple of years ago? Was it the Japanese who tested that?
Yes, there was. Exactly, because I think I'm right in saying, and one of the ideas of if an asteroid is to come too close is to try and nudge it by actually changing the surface of the asteroid. And this is quite an interesting idea, but basically, depending on how dark the asteroid is, depends on how much energy it absorbs from the sun. And using energy, absorbing energy from the sun, is actually a way of generating just a very gentle nudge. So some of these ideas to try and displace an asteroid is to change the characteristic of its surface. Whether that's possible or not, as you say, you really want to get out there and start testing it, really.
And the thing with those, sorry Duncan, the thing with some of those solutions is that they work on having a very small effect, but over a long period of time, don't they? So it does go to assume that it's an object like this where we've got decades of warning to be able to actually get to it. I mean, the first thing you've got to do is actually get to the thing, to actually place one of these sails or the nuclear devices to, provide some kind of other thrust to them, and all the other ideas that are out there.
Where's Bruce Willis when you need him, basically?
Yeah. Hey, Paul.
Sorry, go on, Pat.
People are asking, they want to find out where the asteroid is again, so perhaps you could put your cursor on it since we're screen sharing it. Yeah, if you're in the Hangout, you'll see it.
It's the round dot just right of center. So this is this tiny, tiny little thing between 270 meters and 340 meters. We still don't really know how big it is. The way we actually work out how that asteroid, how big it is its brightness. That's the only way that we have of doing that at the moment. Now, on some of the closer passes, things like the Arecibo radio telescope, they might be able to image it better, so we might get to see its shape and size a little bit better. But an object of this size, we estimate its size purely by how bright it is. So we take the average brightness, surface brightness of asteroids that we know of, and we say, well, that's where it is. We know the distance of it. So if it's that bright, that's how big it's got to be. So these are some of these kind of really unknowns that we deal with. But in the center of the images, we're going to see the round dot. That's the asteroid. In the background, the kind of streaked things are the stars. And you may notice those are getting slightly longer as the evening draws on. And that's because the relative velocity as the asteroid gets closer and closer to its closest approach actually increases.
So you're saying the second show that we're doing, which will begin at 6 Pacific, 9 Eastern, 02 UTC, we'll maybe see some more pronounced star trailing.
Yeah, the star trailing will probably be more pronounced, yes, Pat.
Okay, great. So guys, we're about 5 minutes left in this first broadcast of the asteroid. I just want to give a shout out to Duncan for joining us on this broadcast. He's always great to have on. He's been on a lot of our shows, and we're hoping to expand his presence on a lot of future stuff that we do. We also have Slooh engineer Paul Cox on as well, who's commanding the robotic scope in the Canary Islands. and myself, Patrick Palucci here. Please, guys, one thing to consider is Slooh membership. It helps fund all the programming we produce, free to the public, but also you get the opportunity to command robotic scopes in the Canary Islands. You can snap your own pics, you get your FITS data if you want, and you get, and I think one of the best parts is you get an opportunity to interact with an avid community of space enthusiasts. And I think that's, one of the biggest values for Slooh is that alone. So please do consider before we get off here, if you want to keep updated on our future shows, just come to Slooh.com. You can always see the next one counting down. They change frequently. You know, we do everything live, so weather plays a big role in what we do. So we have to switch shows around all the time. But we will put out tweets, Facebook posts, G+ stuff. You know, so any of that stuff that you like to follow, just follow us, and we'll keep you updated as best we can as well. So Duncan, with about 5 minutes left in this particular broadcast, perhaps you can give me your final thoughts on, you know, I know you're not too worried about this asteroid, but I find it kind of ironic that just last month it was the end of the world with the Mayan calendar, and there was a huge uproar over that. And we actually did some live broadcasting. You were on it. It was fun. We were showing you the solar system live to make people not panic. Just having a good time with it. But this actual event is actually a real. I mean, this is an actual true thing that's orbiting our solar system that, as Paul is alluding to, that we're not totally sure yet. I mean, yeah, we're pretty confident, but, you know, I lost a little confidence last year when LZ1 popped on my front door in June, I think it was. It was 2 days' notice, man. I think was that 2 days' notice or 3 days' notice? And that was a big asteroid that was discovered by Rob McNout in Australia. So he came on our show, and we were imaging it within 24 hours, I believe, and it was an amazing show, but it kind of made me look, wait a second, I thought we knew where all this stuff was in the solar system.
I couldn't agree more. I think the point that I'm making is tonight, you know, we don't need to worry about this asteroid. In the future, I think Paul's absolutely right. You know, until we really, really have our observations in, who knows exactly what it's going to do. And the other thing is, you've picked up on, Pat, you know, we have blind spots. We're not going to be able to predict every single one of these asteroids. I mean, you know, if our numbers are right, if the estimates are right, and there are millions of them out there, it's going to be almost impossible to try and predict every single one of them. But the more you observe them, the more we'll try and find out about them, what we can do if one comes close. You know, the idea of blowing one apart now seems quite a crazy idea, because we've learned that some of them actually are just collections of rubble. They're very loosely held together. If you start knocking those things apart, you're not going to have one. You know, you're going to have 50 bits. And then you've got to try and understand what those 50 bits are going to land. So learning more about it's the only way to go. So I mean, I don't want to seem sort of play it down. We know these things have devastated the planet in the past, but I think for tonight we're safe. In the future, who knows? The only way to find out is to keep watching and learn more.
Well, I mean, to go on that equally, Duncan, I'm not trying to say that there's risk tonight. There definitely isn't. We know that. In fact, I would go further than that. We know that there's no risk in 2029 either. But it's the next one that the uncertainty is still there. And actually, this close past tonight is, we're hoping that it's going to provide the level of observation and the level of accuracy of observation where actually we may even be able to pin down that later closer pass as well. There are so many telescopes pointing at this thing. But, you know, there's a level of uncertainty. What interested me most about this particular object was how much that uncertainty changed, even with some of the biggest and best observatories and astronomers around the world looking at it over the last 8 years. I think that's been a fascinating ride to watch that. Equally, it's been fascinating to see how the tabloid media has then picked up on that. And I think there has been a total failure to be able to discuss these things properly, openly, and with pure facts. And that's why maybe sometimes I come over that I might be being sensationalist, but I'm not. I'm just saying these events are fantastic and sensational enough. You don't need a tabloid journalism to put some big banner headline on it.
Absolutely, and that's the beauty of science. I mean, you know, a lot of science doesn't need to be polemic and be sensational, because in its true form, it's fascinating. And I think the other thing that you said is really important. What it teaches us is, you know, we live in a very dynamic solar system, and the more we realize that and come to terms with it, hopefully, you know, the more we can try and understand what it means for us.
Right. All right, guys. Well, that is wrapped up the presentation on the homepage. It's already flipped over to non-live views. We will be going back live in about an hour and 15 minutes. Paul and I will be jumping on. Duncan, if you're still awake, I will invite you in if you'd like to join in again, but please don't feel obligated at all.
Duncan, please come back. I feel as if I may have scared you off tonight. I've maybe been a bit aggressive, but I think it's kind of it's asking a lot of the questions. I think I play devil's advocate to an extent and ask the questions that are kind of coming out on the Slooh homepage as well.
Good.
Paul's building a reputation to be snippy with all the panel guests. You and Bob, and Bob were getting into it last time I was on. But anyway, that's cool. That's fine. That's fine. Anyway, guys, well, thanks for joining us. I hope you enjoyed it. We will be tracking it further in about an hour and 15 minutes or so. Come back to Slooh and you can see it live. And I want to thank Duncan again for joining us on this broadcast.
Always a pleasure. Thank you very much. Thanks.
I want to thank Paul as well, and we'll see you guys in about an hour and 15 minutes, or at least Paul, and we'll continue tracking it for a little bit and showing you guys what's going on. And Paul and I will. Paul's probably gonna. Duncan, I need you back because I know what's gonna happen. He's gonna start.
I'm going to be saying I'm busy, Pat. Over to you, mate. So Duncan, please come back.
Exactly. He's going to attack me. I don't want to be attacked by Paul Cox. All right. So we'll see you guys later tonight with the second part of this broadcast. For Slooh Space Camera, this is Patrick Palucci. Thank you for joining.
Broadcast of Apophis will begin in about 2 minutes. You should be viewing this on Slooh.com. That's SLOOH.com to get the live visuals. We will be attempting to screen share it at times, but to start the broadcast out, some of the visuals you'll have to go to Slooh.com.
Duncan, did you watch Stargazing Live tonight?
I didn't. No, I forgot to watch it. I forgot.
No.
It's normally quite good. I mean, I think it's one of the more successful live events that the Beeb did. I mean, but I know they did this Volcanoes live.
Duncan, your documentary on Neil Armstrong was one of the best bits of TV I saw in 2012. It was superb.
Oh.
I've seen so many documentaries over the years, but just about every single piece of footage, just about every single still you showed, I could not remember seeing before. Now that might be my failing mid-40s memory, but I think it was a lot of new material in there. So, and they were fantastic interviews.
Thank you. No, we were pretty lucky with the access and with getting the archive as well. I mean, we really trawled, and I think, you know, fortunately, we're in a position now where after sort of 15 years of going through the NASA archive, we tend to get what we want and know who to talk to get it, which is half the battle, and to get the access.
It looks like Pat may have come and gone. Oh no, he's still in there. Got two of you in the hangout, Pat.
Yeah, I've got two as well.
It's nice to have you, double Pat. Yeah, Bob and I continued broadcasting for about 20 minutes on a show where the hangout had crashed, and we both thought it was the best 20 minutes broadcasting either of us had ever done, but it didn't go out to anybody.
we had the same when we had one of the Apollo engineers, and we were just chatting away, and he's brilliant, this chap, and it was fantastic. And then I realised this isn't going out at all. It was really disappointing. But hey,
very frustrating.
Yeah, I didn't think that was that.
Yeah. It didn't quite come off, did it? But
it's not a very difficult thing to do, I think, actually.
Yeah.
But I normally watch the Stargate. Did you see it? Was it good?
Yeah. They're a good mix, I think. Yeah, I mean, it's unfortunate they didn't have many live feeds. They should have used some of ours, perhaps. But they're always entertaining. In fact, I always love the after show half an hour that they do. That's way more entertaining usually. So that was great fun.
I'll have to catch up on iPlayer. As well, to get interviews with the family. Again, it's really just
that was the other thing that I had never seen before. I don't ever recall seeing an interview with any of his family, and to get his brother, there, and his ex-wife. I mean, it was just such an insight into, such a private, what always seemed a very fragile man, and he kind of came over in that, I think.
Superb.
Absolutely loved it.
Thank you very much. Thank you. It's fun to make.
So the Slooh Space Camera broadcast of Asteroid Apophis will begin in about 3 minutes. About 3 minutes.